Hello, we're Group 14, and we're working on intelligent spatial analysis during hurricane events. So what we're doing is we're using AI to quickly and efficiently analyze millions and millions of Twitter data to get an insight into what people are saying during a hurricane, to better understand the impact that hurricanes have on a community.
Hello, my name is Nathan Labar. So far, we've completed all our subsystems that manipulate the CSV files. We have since run larger datasets through our system to perform analysis, including a Hurricane Michael dataset containing about 325,000 tweets and a Florence one containing approximately 120,000. Each tweet in the CSV was given a topic and sentiment label and county location information. With the new information in the CSVs, we were able to filter by county, coastal status, topic, and sentiment, or a mix of them. We've also figured out how to animate the data within QGIS to show up over a certain time range, which further enhances our analysis.
So moving forward, our main challenges left are connecting all the subsystems into a fully integrated workflow, making it end-to-end, as well as finishing our analysis on Hurricane Florence and developing a user interface for all of our subsystems. So now taking a look at our relevance classification subsystem, I kind of want to just give a quick overview of how it works before we move forward. So first we start with our label with training data, and then we convert the text into numerical features, which helps to capture the important terms. And then lastly, we pass those features into our regression model, which learns to distinguish the relevant tweets from the irrelevant ones. So now taking a look at how we use QGIS from our last demo for the relevance classification, we basically took all of the tweets that were classified as relevant and plotted them directly onto the map to just see where they were. And at this stage, no additional layers or advanced analysis was being applied, and it mainly served as a starting point for the more advanced spatial analysis we developed later. So now looking at how we started to improve the QGIS usage for this subsystem, we started to incorporate cones of uncertainty using several KMZ files that we found to represent the hurricane paths and forecast zones. And then we overlaid this with our classified relevant tweets, as you can see with the green dots on the bottom. And then the images here show Hurricane Michael on the left and Florence on the right. And then this was before we added the temporal aspects, which we'll see on the next slide. Alright, so here we see our temporal integration in action. On the left is Hurricane Michael and Florence on the right once again. And we've added the time component to both the hurricane cones and the relevant tweet data, so you can kind of see how the events evolve over time. And then relevant tweets appear dynamically, making it easier to see which areas are affected. And this also helps to validate that our classified tweets align with the real hurricane activity much better. So the previous example I showed was showing how this could be applied for only the relevance classification subsystem. So here I kind of wanted to show an example of how we could bring all of our subsystems together for analysis. So first we filter for hurricane related tweets on a specific topic. In this case it was storm forecast. Then sentiment analysis color codes these tweets, and it showed that many of our users felt anxious under this topic, which is highlighted by the dark blue dots in the image. And all of this data was shown alongside Hurricane Florence's cones of uncertainty. And I just wanted to include a simple example to kind of show how this combined view brings insights on public perception during the storm.
So we're giving the LLM the body text of each tweet, and we're asking it to label the category that it belongs to. And according to our tests, it's doing that at 87% accuracy. And a lot of the inaccuracy is actually whenever it's not sure, it's falling back on off topic or other. And also there's some cases of ambiguity. For example, if a road closure is caused by flooding, well, it can only pick one of those. So it might get that wrong.
So I've been working on the Hurricane Michael analysis. We've managed to create a county layer. That's been helpful for us to further our analysis. So here we would have, say, Sarasota County. It is considered coastal. We can overlay our Twitter data on top. And this is categorized by sentiment, but as you can see, it's kind of clustered, doesn't really do much for us. We can do the same with the topic. Turn this one off so you can see topics. And then since we want a narrower analysis, we'll see where the path of the hurricane actually hit. So I click play on the animation. As you can see, it runs through the counties that are in this area. So we'll zoom in a little. We see we have a lot of anxiety related tweets, the purple, especially in these counties and these counties. So then we will see what people are actually anxious about. So we have Florida, and this is filtered by anxiety. So now we see that these are colored by the topics. So the light blue is flooding. These are official announcements. And then the purple is power outages. So we're going to take a closer look at the power outages specifically in, let's see, this is Leon County. So over here, I already have that set up. We'll turn this off for now, but we have power outages in Leon County. And then we also have tree damage. So it seems like there's a correlation here that the trees could be causing the power outages. Let me turn off power outages. See, there's even more in the same spots where the power outage points were as well. Some of them go on top of each other if they have the exact same location. And then I made some plots that can confirm our analysis. As you can see, the share of tweets by county about tree damage is shown. So Leon County doesn't even have 1%, but it still has more of its tweets. Well, not even 1% of its tweets are about tree damage, but it's still way more than all these. But here, about almost 3% of the tweets about power outages. We have the sentiment mix. So you could see that Leon County still has the top for power outage and tree damage, but for power outage, they actually have quite a few people that are happy. And if we looked at the tweets, they'd be talking about the response time and how quickly their power came back or how long it lasted, and other people that were just optimistic.
All right, so this is Hurricane Florence, and one thing we can immediately see looking at the map here is all these blue dots. These are tweets that are tagged as anxiety, and those are mostly concentrated in the direct path of the storm, whereas the green and yellow, that's humor and joy, they're concentrated more outside of the direct path. But let's say we want to isolate and just look at the tweets that are in this red shaded area. This is hurricane force winds, or this shaded area. These are just the tropical storm force winds, and we can look at just those tweets in isolation. Well, how do we do that? Well, we can do an extract by expression, and so this is going to isolate just the 64 knot winds from this layer. So we'll click run, and there we go. That's right there, the 64 knot winds. And so we can do that 3 times, and so we can get the 34 knot winds, 50 knot, and the 64 knot winds. So if we want to obtain a layer with just the tweets from the 64 knot winds, we can do an extract by location. So we're extracting the features from here that intersect or are within the 64 knot wind layer. So we run that, and there we go. And so we have all the tweets isolated into 34 knot winds, 50 knot winds, and 64 knot winds. And we can look at these and look for correlations between what kinds of tweets are happening in tropical storm force winds versus hurricane force winds. And here we can verify what we saw earlier. As the wind speed increases, so does the amount of anxiety in the tweets. We have lots of anxiety here in the hurricane force winds, and the humor is decreasing as the wind speed increases. So people that are experiencing hurricane force winds, a lot more anxiety, a lot less humor. And something interesting about the topic distribution by wind zone is the people experiencing higher speed winds, they're actually talking about politics a lot less than the people that are experiencing the lower speed winds. And I think that's because they have more immediate concerns. They're talking about the flooding and the tree damage, and they're keeping tabs on official updates a lot more than the people experiencing just tropical storm force winds.